Hey guys, I welcome you to my YouTube channel Shahi Works. Today we are gonna learn about recursion. So recursion involves a feature calling itself again and again. So it will be calling itself directly or indirectly to solve a problem by breaking it down into simpler or more manageable parts. So this is known as recursion, and recursion is widely under for tasks that can be divided into identical subsets. So in recursive function is defined like any other function, but it includes a call to itself. So in short, a recursion is a function which calls itself again and again. Now let's see an example for recursion. This is a basic example. Def factorial n, if n double equal to 0, it will return 1, else return n into factorial n minus 1. Here the factorial of 5 is 125 into 5 into 5 into 5 into 5. So 120. Now let's see the basic structure of recursive function. Def recursion function name parameters. If basic condition result, that it will be return the base result, else the result condition. Now base condition and recursive case. Base case and recursive case. This is the condition in which the recursion stops. In base case, it is crucial to prevent infinite loops and to ensure that each recursive call is reduced. Also, since there is an example case in n of 1, recursive means the function that includes the call itself. Example n into factorial n minus 1. Def Fibonacci n double equal to 0 means return 0. LF n double equal to 1 means return 1. LF return Fibonacci n minus 1 plus Fibonacci n minus 2. Print Fibonacci 10, that is 55. Why? Because in base case n equal to 0 means the function returns 0. If n double equal to 1 means returns 1. In recursive case, there is a condition that n minus 1 and n plus 1, so that is 55. Now let's see about types of recursions. There are two types, tail and non-tail. The tail recursion occurs when the recursive call is the last operation accelerated in the function executed, with no additional work or calculation to perform. Also, in many programming languages, tail recursion can be optimized to the compiler to improve the performance and to prevent the stack overflow, whereas in non-tail occurs to call itself when it performing the operation or calculations. Now let's see an example. Def tail fact n of acceleration 0, base case n double equal to 0 means return account, else return tail fact of n minus 1 account into n. ACC. Def non-tail fact means base case, here it will return 1, also else it will return n into non-tail fact n minus 1. Now in the example usage, print tail of fact 5, also print tail of non-tail of fact 5. So 120, 120. Both case you will be using the base case and LF condition. Now let's see about the difference between recursion and iteration. Recursion is often more initiative, easy to implement. Also, it can lead to solutions that are easier to understand and compare to iterative. Whereas iteratives are involves the iterational loops, that is for and while. It is generally more memory efficient and it does not involve multiple tasks like recursion. Now let's see about the advantages and disadvantages. Recursion is mainly advanced because of a simplicity and reduced code length. Generally, the code is very simple and it is very clean for the beginners. Also, code length, reduce the code of length. Disadvantages: memory overhead, performance issue, and risk of stack overflow. The recursive call adds a new layer to the stack, so the memory is always overloaded. Performance issue means recursive function may slow due to the sum of the function calls and returns. Risk: excessive recursion may lead to error. So thank you for your attention till now. Also, if you found this video, don't forget to like, comment, share and subscribe for more useful contents like this. Thank you.